Hello and welcome to Thursday's edition of Cracking the Cryptic, where we've got a fog of war puzzle to have a look at today, which features one of my very favourite constraints. The puzzle on screen is by Belamis. I think I've done Belamis puzzles on the channel before, but not for a few months, I want to say. It's called Consecutive Regional Constraints. And why am I so keen to have a go at this? Well, there's a few reasons. Firstly, we've had two email recommendations that claim this is a masterpiece. That's quite good, isn't it? Secondly, it's got this rule set I absolutely love, where if a digit appears on a constraint, so if on this blue line we put, I don't know, 9, if this was a 9, then no other blue line can contain a 9. But this one, I love that rule. I think that is such a beautiful rule. We've had lovely, lovely puzzles with that rule, especially I want to say by Fenners, the Olympic athlete, who also happens to be sort of Olympic level Sudoku constructor. Anyway, that's a rule I like very much. But this one has a twist on that rule as well, in that we've got to have some sort of Remban effect across the digits used on a constraint, which I haven't seen. I've never seen that rule before. But I will say that when we had this recommended, one of the testers had a go at it and found it monstrously hard, and I think even tweaked the rules. But we've just had it tested again. Second tester says it's good to go, so I am going to do just that and have a go at it. I found it on Logic Masters and it hasn't even got a rating yet, so I think that means it must be hard. But as I say, I love the rule set so much. Fog of War combined with consecutive regional constraints, that's it. That's all I need to know. So Belamis, you and I, we're going to do battle in a moment or two's time. We'll read the rules together. Before we kick off, what else can I tell you about? Few things, probably. Actually, I will indulge in a moment of embarrassment. On Facebook today, Facebook sometimes throws up pictures from your past. Well, this picture popped up today, and I thought some of you might be amused to see it. Is it this one? That is yours truly. Dressed as one of the 3 Amigos. What a film. I mean, when I saw this, it just made me smile because I remembered El Guapo and the singing bush and the invisible swordsman, etc., etc. But yeah, now, and then I wondered whether there are people, aren't there, who can work out where pictures are just from very small details in them. Is that geocaching, or is that something different? It might be something different. But anyway, I wondered if anybody out there was a sufficiently expert enough geocacher, or whatever the word is, to work out where that is. If anyone gets that, they will get a like in the comments for sure. I will be very impressed. Yeah, you could even try and guess how many years ago that was. And I will be also quite impressed if you can guess that. Anyway, that's enough of the 3 Amigos. Maverick's flying over. Normally the sign that it's going to be a good video, or at least it's going to be a good puzzle. So sorry if there's a little bit of aeroplane noise in the background. Over on Patreon, do get involved in our monthly competition. Shall we see? I might have the thingy that allows us to see what the league table is saying. I have got the thingy. Let's refresh the thingy. So we were at 126, I just spied there. 167 solves of all the puzzles. And 1,300 solves of the first puzzle. There's a bit of a drop-off before the... I can't remember which one was it that one of them was giving people a lot of trouble. I can't remember if it was Ace of Clubs or Ace of Spades. But we slightly amended the puzzle just to make it a little bit easier. So if you haven't seen that and you were stuck on one of these early puzzles, we certainly don't intend for the early puzzles to be sticking points. So we've slightly tweaked it to make it a little bit more accessible. Yeah, if you've got until the 20th, if you want to be with the chance of winning the competition and coming onto the channel and appearing in a video. So good luck. And do get involved over on Patreon right now. Let's do some birthdays. I'm actually going to start off. This is a good segue into the birthdays. I'm going to slightly reorder my birthdays. I'm going to start off by wishing Maddie a very happy 29th birthday. And why am I starting with you, Maddie? Well, your partner Morgan wrote to me and said you might like a shout out. But Morgan also revealed that you were the Maddie who won last month's Patreon reward. So many congratulations again, Maddie. I have written to you this morning to try and settle on a date when we can get together and try and record a solve. I've also set Mark onto the task of picking a puzzle for us. But yeah, that's it's very cool to be able to read out your birthday. I know you're a K-pop fan. I don't know much about K-pop. No, I really can't claim to. But Morgan said that in terms of, which is your favorite area of YouTube, it's between K-pop and Cracking the Cryptic. And all we need to move into first place is to have more choreography in the videos. So I've explained that to Mark, and I gather he's all over that. He's going to be dancing away like BTS. Look, I know all the lingo. I don't really. But Maddie, many happy returns, and I hope you have a great birthday with chocolate cake, of course. Now, next birthday, Lavender. Lavender, I think it's your birthday today, and I know this because August contacted us to let us know. But I have to confess to you, I have looked all over the place this morning to try and work out where the message is from August about your birthday, Lavender, and I can't find it. I wondered whether it was in a YouTube comment, or whether it's in an email, or whether it was via Instagram or Facebook. I've not been able to find it, so I'm so sorry about that. So I can't give any more details, but hopefully, Lavender, you know somebody called August, and this all makes sense to you. Next birthday, Alice. Alice, your fiance Ethan wrote to me to tell me it was your birthday, but Ethan actually used the word. He said that you were his finance. I think he meant fiance, but it struck me as quite a funny typo. I hope you have a great birthday, Alice. I think it's 44 days until the big day, the day you get married. And I gather you're having a salted caramel cake, but also it's got another part of the cake, which is raspberry and white chocolate. I mean, that does sound pretty good. It may not be classic chocolate cake, but I can't really moan about that. And Alice, many happy returns. And the best of luck to you both with the wedding, obviously. And then last but not least, Mohammed. Mohammed, you're turning 35 today. And I know this because your wife, Zineb, wrote to me, told me you're an eye surgeon over there in Germany. And you're a lover of chess and Sudoku, and also a brilliant cook, apparently. So, Mohammed, many happy returns. I hope you find some heavily iced chocolate cake today. I hope you don't have to do the cooking and make it. And enjoy your birthday. That's all the news. Shall we have a go at solving Belamis's puzzle? Let's read the rules together and see what we've got to do. We have got normal Sudoku rules applying, so we're going to put the digits 1 to 9 once each in every row, every column, and every 3x3 box. Actually, I get paranoid that I've left the cards up, but I haven't. That's good. Now, dynamic fog. The grid is partially covered in fog. Correctly placed digits may remove fog from other cells. So if we got this digit here, it might clear the fog from there or there. We just don't know. But Belamis will have designed the puzzle so that it's logical. So what we mustn't do, or what it would be such a shame to do, is to just guess. We don't go to this cell and write 1, 2, 3, 4, 5, 6, 7, 8, 9 until we get it and reveal what's under the fog. That is not the idea. The idea is we should be logically able to deduce something just from the cells that we can see. Right, now here's the rule I really like. Any constraint type cannot have a repeated digit. E.g., if a 2 appears on a parity line, another 2 may not appear on any parity line. Oh, my phone's buzzing. What's that to do with it? Oh, that's nothing. In addition, now this is a very unusual rule. In addition, digits across a constraint type must make up a consecutive set of digits. E.g., If a 2 and 4 exist on a Dutch whispers line or lines, there must also be a 3 somewhere on a Dutch whisper line. That is fascinating, isn't it? So, yeah, so on the overall constituents on any particular type of line are going to be a consecutive set without a repeat. Yeah, I'm not. That feels like a very big constraint. But anyway, let's keep reading the rules. Now, there's now a long list of the constraint types that exist in the puzzle. So let's read through those. Arrow. Is that going to be an arrow? Digits along an arrow sum to the digit in the connected circle. Each circle is associated with exactly one arrow. So I think this is an arrow. So let's extend the arrow. Let's say it does that, and let's do 1, 2, 3. 1 plus 2 plus 3 equals 6. So we do that and write 6 in there. The reason I'm writing these in small numbers is just in case I luck out on a number and it clears fog. That is not what we should be doing here. Now, region sum, RS. So this is very kind for colourblind folk. Look, Belamis has made sure there's labelling. The 3x3 box borders divide a blue line into segments. Each segment along an individual line must have the same sum. Each line crosses at least one box border and does not branch. Okay, so let's do an example of that. So let's say this one does that. Is that legitimate? I've no idea, but it might be. So the 3x3 box borders divide this line into segments. So we'd be doing this and that, and then each of these segments must have the same sum. So the purple would add to the same as the 3 yellows would add to the same as the 2 greens. And then, of course, overall, we'd have to make sure that those 6 digits were different from this digit and whatever goes off in this box, and that overall they all form a consecutive set. It's completely nuts. Okay. Next rule, Renban, R. So we can't see any of these. Purple lines contain a non-repeating set of consecutive digits in any order. So that's a weird rule, because if there are Renbans in the puzzle, they have to individually be a non-repeating set of consecutive digits, but then the collective of all the Renbans has to also be a non-repeating set of consecutive digits. So there's sort of a meta Renban going on. And then Dutch whispers. Well, let's do an example. I should keep doing examples. So Renbans. So if this was a Renban line and this was a 1, then these 2 digits would have to be 2 and 3 in some order to make sure that the set of digits on that line were consecutive and non-repeating. Now, Dutch whispers. So Dutch whispers normally are orange, aren't they? So let's go to orange. Adjacent digits along an orange line have a difference of at least 4. So if this was a 1, this would be at least a 5, 6, 7, 8, or 9 is how it would work. Entropic. Any 3... Oh, peach. I don't know if I've got peach. Ooh. No, I don't think I've got peach. I'm going to have to use a proxy for peach. Yellow? Yellow's not really a proxy for peach, is it? But, okay, an entropic line. Any 3 adjacent digits along a peach line are from 1 each of low, 1, 2, 3, medium, 4, 5, 6, and high, 7, 8, 9. Entropic lines must be at least 3 cells long. Okay, so this is 3 cells long, and let's say this was 1 and this was 8. Then we wouldn't know exactly what this was, but we know in the 3 cells there must be a middly digit. That's low, that's high, so this would be a 4, 5, or 6, is how entropics have to work. And there's a couple more. Crop key. digits in cells separated by a white dot are consecutive. So if these two cells were separated by a white dot and this was a 2, this would either be a 3 or it would be a 1 to be consecutive with the 2. And a parity, a red line. Okay, so let's do a parity line. Along a red line, adjacent digits must alternate between odd and even. So if this was a 1, this would have to be an even number. So let's say 4, and then this would have to be an odd number again. So that could be 7. And we get a snooker maximum just like that. How easy. Snooker is a very hard game. Anyway, I mustn't get distracted. They are all the rules. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Well, let's start by doing some extending of lines, shall we? We can do all of those things without fear of contradiction. And each of these is not. I mean, there's going to have to be more. Is what I'm trying to say. We can't have situations where we could, or to put it a different way, we couldn't even have a situation like that on a region sum line, because we're not allowed to have repeated digits on a constraint. So although those digits could be the same by Sudoku, if there was a 2-cell region line, that wouldn't work in this puzzle. So we know that this thing has to go somewhere else. This thing has to go somewhere else in order that these are not the same digit. So we know. So we know for the region sum lines. Oh, I wonder actually. I've been making an assumption here that might not be valid. Let's just check that. Is that possible? Oh, actually, that's not possible for a different. Even if it's possible from a length perspective, I can see why it's not possible. 1, 2, 3, 4, 5, 6, 7. Actually, it would have been possible from a length perspective. No, but this is wrong, because if we did have such a line, we can't have more than 9 numbers on any constraint, because there are only 9 Sudoku numbers, aren't there? And we're not allowed to repeat a digit on a constraint. But here, that is a segment and that is a segment on the same line, so they would be the same digit, and we would repeat a digit on a constraint. So that's not possible. So these are right. So these are definitely different lines, and there are definitely 6 digits at least on these 2 lines, because we know this extends and we know this extends. And sorry, I'm just looking at the rules again. And overall, it's a consecutive set of digits. So that's wrong. Okay, so that's not the end of the story. We can say that. There aren't only 6 digits on these region sum lines because of parity, actually. And the way I'm seeing that is a region sum line. Well, actually, it's funny that I can see that quickly, but let's just draw some region sum extensions in and say that this is the complete. These are complete. Why do I think this won't work? Well, it's a region sum line. Let's say that this was x and this is y. What does this line sum to? Well, it sums to 2x because those 2 cells add up to the same as that one. So that line sums to an even number. And this line sums to 2y. So that sums to an even number as well. 2y is definitely even. Now, I don't think 6 consecutive numbers can possibly add up to an even number, because 6 consecutive numbers will be 3 evens and 3 odds. It doesn't matter if they're consecutive, that's what they must be. And if you add up 3 odd numbers, you do not get an even number. And if you add up even numbers, you always get an even number. So the sum of 6 consecutive numbers is always odd, and yet they should be even if this was the complete panoply of the region sums. So it's not. So the region sums are definitely, well, I mean, it's quite interesting. There are at least 7 cells then. In fact, okay, I'm going to go slightly further then and say that just using the parity point, there isn't another region sum line in the puzzle. So we couldn't have this as a region sum line. Because of the thing we said before, where you can't have a 2-cell region sum line, if I was to have another region sum line, it would be 3 cells at least. So let's say that, and that are the 3 region sum lines in the puzzle. Now you may immediately go, well, that's fine, Simon. There are 9 different cells. There are 9 different Sudoku digits, so that's totally possible. But it's not, is it? Because individually, each region sum line will sum to an even number. And the secret, something I share with only my very favourite people, but if you're watching this video, of course I'm going to share it with you. All 9 Sudoku digits do not sum to an even digit or an even number. They sum to 45, and that's odd. So that's definitely wrong. So actually, I'm sort of getting there slowly. There are right. Let's summarise where we are. There are exactly 2 region sum lines in this puzzle, although I don't know what shape they've got, so let's just undo those. They've got some sort of shape, and they aren't only 6 digits, they're at least 7. Now, if they were 7, then if they were 7, sorry, I'm sorry, I'm trying to do parity and I'm not getting very far, because I know that the numbers 1 to 7 sum to 28, and that's even, so that feels like it might work. And now I'm just trying to think through why that either works or it doesn't work, and my brain isn't telling me answer, and it's being very annoying. Now Maverick's flying over and I've got too much going on in my brain. But if it's 7 different numbers, it doesn't have to sum to 28, because it doesn't have to be 1 to 7. It could be 2 to 8, couldn't it? Which would miss out the 1 and the 9 from 45, so it would sum to 35. That wouldn't work. That's impossible. Because, although this gets very complicated, actually. Because if it's more than 7 numbers, couldn't you have... Well, couldn't you have that, for example? I mean, I know this has got to extend. So now I've got 3 here, and I've got 8 cells altogether. But then the thing that I'm getting concerned about is that now doesn't have an even sum. Because, well, it doesn't necessarily have an even sum. If this is an odd number, it's 3 lots of odd numbers. So it's that would have an odd total, this would have an even total, and that overall would be an odd total, which would bring 35 into the equation, except I don't think 35 works, because 35 was 7 cells. And I don't think with 7 cells. So let's just start here. That's 6 cells. That's not enough. So if we're going to have 7 cells altogether on region sums, one of these would have to extend. And what it couldn't do is something like that, because then these 2 cells would have the same value, and we can't repeat. Even if I could get that into another box, this cell can't repeat on region sums. So this is not a valid thing. So if it is just 7 cells, one of these has to extend by 1 cell. And therefore, we are looking at even totals still. because these are only occupying 2 boxes. So we are looking at 28 as the overall sum, or what if it was 3 to 9? 3, 4, 5, 6, 7, 8, 9, missing out 1 and 2 from 45, then we'd be on 42, which is also even. I don't even know. Oh, hang on. The other issue is that I'm now thinking about from a sort of constructing point of view rather than necessarily a solving point of view, is let's say somebody came up to me and said, Simon, I'm going to give you a gift. Here is your gift. I am going to tell you exactly. I'm going to tell you what the region sum numbers are in this puzzle that you have to use. I'm not going to tell you where to put them. I'm just going to tell you what they are. So that they might say they are the numbers 1 to 7, and how would I ever know? How would I ever know why that one and that one were whatever they are? I could totally see how it might be possible that somebody would, if I knew exactly what was on them, I might be able to say that's a 6-7 pair or something. But how would I know which was which? What would it be about the inherent quality of the region sum lines that would tell me which of these was which way round? No way, there's nothing. There's nothing. So I now think it might be this. I wonder if you narrow that down to say a 6-7 pair, that would be looking at the arrow circle. So, well, maybe, I don't know. That's quite a weird thought, isn't it? How am I ever going to know which way round these go? Or is that not the point? The point might be you're not supposed to know. The thing is that this could be trivial, I think. Why couldn't this be? Overall, the digits on arrows have to be a consecutive set. So if this was the only arrow, why couldn't it be 1, 2, 3? They're consecutive. 1 plus 2 equals 3. In fact, I tell you what is quite interesting. The logic on this is a weird point. This is a weird point. A one cell region sum line, like these are, is very similar mathematically to an arrow. What's going on here? Oh, have we got an arrow because Belamis didn't want to use region sum again? There's some point here, isn't there? About I don't know, actually. I'm not sure. I'm sorry. What's the point? What is the point? What's the point of me? That's a good question. But also, this is a weird. The more I think about it, the more I think I've not understood something about the puzzle, actually. There's some subtlety here that I don't understand. because one cell region sums feel exactly like arrows. So I feel like if I think about arrows and I sort of say, okay, I mean, obviously this could be the only arrow in the puzzle. Okay, all right, well, let's just quickly do that, because I think we can just do the same logic. Are there 3 arrows in this puzzle? No. Because of the rule, so say there was an arrow here, and it was a 1-cell arrow, well, that wouldn't work. These would be the same digit, so that's impossible because of the constraint. So any arrow is at least 3 cells large. And once you've got 3 cells of arrow, it's adding to an even digit, isn't it? These are going to add to that. So it's the same as region sum logic. So again, if we had 3 arrows, we're going to use 9 different digits, which should add to 45, but each arrow individually is going to be an even total, so that's not going to work. What is the point here? Each arrow... There is a difference, actually, between the arrow rule and the region sum rule. Each circle is associated with exactly 1 arrow. That is different. That is different to the region sum rule. Because if an arrow did that, yeah, this is interesting. Do you remember down here? I was thinking about whoopsie. I was thinking about that shape, and I noted that could add to an odd number. That can't. This is it. Right. That can't exist on arrows. No individual arrow. No, this is it. This is it. There's some parity trick here. No individual arrow in this puzzle can have an odd total overall. Because you can't have something like this, because there's this rule that says each circle is associated with exactly 1 arrow. So this is an impossibility. But imagine this being a 7. That would add 7. That would add 7. The overall digits on the arrow would sum to 21. Odd. That's not possible if you can only have one. If you can only have 1 arrow emanating from a circle. Because it doesn't matter how long the arrow is, the sum of the arrow will always equal the sum of the circle. So the digits on all arrows in this puzzle are summing to an even total. So, because each individual circle and arrow are going to have the same sum. Now, okay, so this at least is checkable. This at least is checkable. So let's say there was an arrow here. So now I'm going to hide. I've worked out there aren't 3 different arrows. If there were 2 different arrows, that is impossible. For the same reason as the region sum. Because these would be 6 consecutive numbers. They would have 3 odds and 3 evens. So they add overall to an odd total, but each total individually ought to be even. So the parity is wrong. So this doesn't work. So if there are 2 different arrows, one of the arrows at least has to extend and be more. It has to take another cell. So we're either looking at 7 or 8. I don't think we're looking at 9. Because if we do extend this again and have these 4 digits would all be different numbers, wouldn't they? And 4 different numbers cannot sum to a single digit total. So I think, given that we know we aren't dealing with 3 arrows, if we're dealing with 2 arrows, we're either dealing with 2 3-cell arrows. This feels impossible. It just does. I think you're going to run out of... Well, you are going to run out of low digits. You can immediately see that. If you had Yeah, that's very straightforward. Any 3-cell arrow in Sudoku needs at least 2 low digits on it, 2 of the digits 1, 2, and 3. Because if it didn't have 2 of those digits, then the least it could be would be a 1, a 4, and a 5, which sum to 10, and we can't put 10 into the circle. So there needs to be at least 2 low digits there, and there needs to be at least 2 low digits there. And that's 4 of the digits 1, 2, and 3. But we're not allowed to repeat a digit due to the constraint here. So this can't work. So the only way that there is a second arrow is if one of these arrows, this one or this one, is a 3-cell arrow and the other is a 2-cell arrow, but we are looking at 7 cells, which are adding up to at least 28. I don't think that works. I don't think that works because, so what I'm now hypothesizing is there are 7 different digits, and I'm going to think of them as being the digits 1 to 7. 1 to 7 in Sudoku sum to 28. And the highest digit in that sequence 1 to 7, trivially, is the 7. So because you can't put 7 on an arrow, because that would imply you needed an 8 or a 9 in the circle, one of these would be a 7. And that arrow would add up to 14 overall. Imagine this was a 7. Those would add up to 7, so that's 14 overall. But that means this one should add up to 14 overall to get to the 28. But that would make this a 7, and we get 2 7s, so it doesn't work. And presumably, we know we're looking at an even total, so if we go to 42, which would be the other way of doing it, if we had 3 through 9 as the 7 digits, that's going to be a bigger problem. Because although you could put 9 on there, and make those add up to 9 as well, that's only 18, so they should add up to 24, and that would be a 12. That's worse. Okay, all right, good. This is very complicated, but I think I am now able to say that there can't be a second arrow in this puzzle. So there can't be 3 arrows, and there can't be 2 arrows, so there's 1 arrow. Now, I glibly noted earlier this could be a 1, 2, 3 arrow. Well, that is what it is then, isn't it? Because there's no other way. I was just thinking for a second about whether I could have a 3-cell arrow, but no, I can't, because these. I mean, even if I make those 2, 3, 4, that's a 9, and I haven't put 5, 6, 7, and 8 on. It's not possible. And if this is 1, 2, 3, that's a 6, and I've not put 4 and 5 on. So it has to be. Yeah, or to think of it a different way, whatever the highest digit is that you put, given that there's only 1 arrow and these digits are consecutive, this digit is the highest of those digits, whatever it is. So the arrow must contain the next lowest number, and then the only way the sum can work is if you add 1 to that next lowest number. So the maximum length of the arrow is actually 3. It's actually quite beautiful. It's quite beautiful in a strange mathematical way. So because you're adding 1 to the second highest number, so this is the highest number. The arrow can only be 2 cells and includes a 1, so it must be 1. It must be 1, 2, 3. And this is going to clear the fog. So isn't it amazing that? So I've been led on a wild goose chase here. Actually, we don't know the shape of this, by looking at the region sums first, whereas actually realizing that I was never going to be able to resolve, even if a genie told me, I wouldn't know which way round these goes. That made me think about this, which actually has allowed me to work out this is a 3. You are kidding. No? Is that wrong then? Or Oh, you are joking. That's absolutely barbaric. I would love to know if that's a correct digit. Oh no, you rotten puzzle. Oh, okay, all right, but maybe that being 1, 2 puts too much pressure on this sum, or puts at least pressure on it so that I can do something. I mean, ruling out 3 from the 2 region sum totals feels totally and utterly like useless, doesn't it? So, okay, this is at least a 7 now. But because this has to extend, but this can't be a 1 or a 2. So it's at least a 3 plus a 4 in this box, wherever this goes. In fact, I tell you what, this is a 2-cell segment. I'm not saying it doesn't leave. I'm not saying it doesn't leave the box and do something like this, but I am saying that is not a 3-cell segment in this box, because it would be at least 3 plus 4 plus 5, and that would make this a 12. So there's a 2-cell segment. In this box. And then that digit can't be a 1 or a 2, so that's at least a 3. So this is at least 3 plus 4. But if it was 3 plus 4, then this couldn't be 1, 2, 3, or 4. Okay, how could this go up? I don't think that works. Because now wherever this goes, let's say it goes there, I've got 3 plus 4, which I can't then... what I'm seeing there is that because all 4 of those digits have to be different and none of them are 1 and 2, they would be at least 3 plus 4 plus 5 plus 6, which is 18. And that would require both of these to be 9, which they can't be. So this doesn't go there. It either goes there or there. And in fact, it goes into a 1 or a 2 then, doesn't it? Because if it went there and that was, again, and these were still, none of them were a 1 or a 2, we'd have exactly the same problem. These would have to be double 9. So wherever this goes, there or there, it goes into a 1 or a 2. And we know... Okay, all right, but at least now we know. So, okay, so let's think through the 7 occulant. If there are 7 different cells, we know there can't be 6, because if there are only 6 different cells, these would add up to an even, well, all of these would add up to an even number. 3 odds, 3 evens, and that doesn't work. So if it's 7 different cells, this one has to be a 3-cell arrow, effectively. And this has to be 2 cells, because it can't be 3 cells in this box. So let's just imagine it does that. Now, is that possible? Isn't this the same point that I was just looking at over here? It's the same point. It doesn't work, does it? It is. Sorry. It's exactly the same point. I don't know why my brain is trying to see that differently, but it is, and it's being silly. But we've just looked at this. Literally, I drew a circle here and drew 3 cells coming down at it, and then we thought about those adding up to 28 or adding up to 42, and we worked out that no, that would make the circles the same. It doesn't work. So this is wrong. Okay, so what that means is that we're looking at least 8 different digits then. But the problem with that is that brings in the option of two segments again, doesn't it? Although I don't, because you can't go there. I don't think you can do that one. But maybe you can do that one. That would be 8 cells, wouldn't it? And also perhaps 9 cells could be a possibility then. Although that I just think that's too, I think that's going to put too much pressure on things. But I don't really know why I think that. No, I can actually, I tell you what, I can justify that, I think. If there were 9 different digits on these 2 region sum lines, then 1, 2. This is complicated because then you could have diagonal segments coming in. 1, 2, 3, 4, 5. No, because this has to be at least 3. So we couldn't have a third segment. We couldn't have you couldn't have a fourth segment here. So this could be a maximum of 9. So the overall digits on this would add up to a maximum of 27 because there can't be 4 segments. And therefore this, to get us up to 45, which it would have to be if we're using 9 different digits, would have to add to 18. But that would require this to be another 9. It doesn't work because you're only looking at 5 different segments maximum on these 3 lines, given each segment, other than the single cell segment, has to be a 2-cell segment at least. So 9 definitely doesn't work. So the only thing that works is 8 different digits, but I don't know whether we have to have 2 segments or not. What I mean by that is I don't know whether this one comes down or whether we're looking at this sort of thing. Actually, this one can't be. That can't take more than 2 in box 3. This is so complicated. So if we were, so 1, 2, 3. Oh, maybe that. I hadn't thought of that. 1, 2. No, because that would only be a 1-cell segment then. I think there has to be, how to describe it, a 5th segment. Because if there wasn't, let's just think this through. We've worked out there are 8 different digits exactly on these 2 Ren bands. So I suppose I know the sum then. It's either 1 to 8 or 2 to 9. So it's either 36 or 44. One of those is the sum of all the region sum lines. But what I was thinking is, if there are only 4 segments altogether, then these are 2 segments, and there's going to be a second segment here. I don't know what the shape of it is going to be, but it's going to be down here. But in that example, hang on, maybe I'm wrong in my... No, that doesn't work, because these have to be different numbers. The maximum size they could be is 9 and 8, and therefore we're looking at double 17 as the maximum value for the 4 segments, which is 34, but I know they add up to at least 36. It just doesn't work. So there are 3 segments. One of these region sum lines has 3 segments. Now, this one can't, because it can't go to that cell for its next digit, because then all 4 of these would be different. I don't know which one of these this takes, but we can't have this going there for its second cell. So this one can't get a second, it can't get to an edge to get to a third segment. So this one does get to a third segment. But could it do something like that? No, it doesn't branch. The rules tell us it doesn't branch. So we don't have something like that. So this isn't allowed to branch. So it's got to stay low. So I think this one does that, then come. Oh no, then I don't know. It could go there or there. But then it does something. It gets back into box 6, and it's going to be a 2-cell segment here. So this is going there or there. This is going in some way into this box and doing a 2-cell segment. And then hopefully the maths will rescue us and explain what on earth is going on. So this thing, whatever this digit is times by 3 to work out the total sum of this line, because it's going to be that, and then something here. Something like that, or like that, or like that, or like that. There's loads of options. This is going to be a times 2 digit, isn't it? Whatever this is. Whatever this, let's just assume some shapes because it's just easier to work with. So this is going to be that x there, that's 2x. And this is going to be 3 times whatever that digit is. Probably 9, I would think. If this is 9... Oh, if it's 9, there's no 1 on any of these, is there? So that would be 27. That doesn't work. That isn't 9, actually. The maths is wrong. Oh, hang on. Is that not going to work with 21 either? 21. But this... It doesn't work. Oh, this is 8. That might clear the fog. Right, this is 8. The way I've got to that is I know that this line adds up to an even number. But I know 8 consecutive digits in Sudoku either sum to 36 or 44, both of which are even. So if this adds up to an odd number overall, that would need to add up to an odd number. But I know whatever shape it is, it adds up to an even number. So because this is even, that has this times 3 has to be even. So this is 8, I think. No. No. Okay, that is 3, 5. Because there's no way this can go up there because this can't branch down. But that doesn't tell me what this is. Oh, does it tell me what that is? So, okay, hang on. So this adds up to 24. So this either adds up... Oh, it doesn't add up to 20. It doesn't add up to 20 because I can't write 10 in there. So we're looking at the digits 1 to 8, which add to 36. This adds to 24, so this is a 6, and that must clear the fog. Yes! Oh my... How hard was that? That has taken me 54 minutes to do that. 50... And I still can't see the shape of anything. Right. But this is... Oh, this is good. This is good. Right. This is a 2-cell arrow that's adding up to 6, and it doesn't use 5. So it's not 1, 5. So it's 2, 4, and that digit's a 4. And it was that. It was, though. It didn't go up there. That's a 2. There we go. Now, this... So the 8th string here, I don't know what the shape of this is, but it's not 2, 6. It's 1, 7. So somewhere in this box is a 1, 7. One of these is a 1, 7. Maybe they could both be 1, 7. I never thought of that. Maybe it could be that shape. I don't know. But at least we've got other things to work on now, so we can definitely do that. I mean, isn't that fascinating? What a beginning! What a beginning that is. Now I've got some Wren bands, and I've got some Dutch whispers. Well, wait. Oh, I can definitely do something with this relatively easily. Right, let's start here, because this cell sees 1, 2, 3, 4, and 5. It sees 4 down here, 1, 2, 3, 5 here, so it's at least a 6. Now, the interesting thing about that one actually is this cell. This has got to be 4 different from one of these digits. So it's got to be a low digit. The highest it could be would be a 5 if this was a 9. But it can't be 1, 2, 3, or 5. That has to be 4. Yeah. Okay, and then this is not 6 or 7 now. Could be 8. 4 and 8 are 4 apart. Now, don't know what that means quite, but it might mean something. I'm sorry if it's really obvious. Oh, nearly. Okay, I'm just going to take a little segue down here, if that's all right, because there's a little trick you can do with a 2-cell Renban. If you think about a 2-cell Renban, basically it's saying these are consecutive digits. But consecutive pair of digits will include an even digit always, won't they? Well, where's the even digit on this string? That cell sees 8 and 2, 4, and 6, so that is definitely not even. So this is even, and this cell sees 4, 2, and 8. So the only even digit it can be is 6, which didn't clear the fog. But it does mean this digit is 5 or 7. Okay, I see. Right, so 6 now is there by Sudoku. Oh, didn't clear the fog again. Well, it did. It cleared the fog from that cell, but it didn't clear any more fog. Right, 1, 2, 3, 4, 5, 6. So these are 7, 8, 9. Oh, I see. There we go. So 7 in box 3 now is on the right, looking at that cell. So this is a 5. I thought, I see, this might clear the fog. 5. Oh, yeah. That's good. That's good for us, because now this is a 1 or a 7. Well, okay. It's nearly good for us. What about... Oh, no, I don't, actually. I thought I was going to be able to say something definitive, but... Oh, hang on. 8's looking at those. These are 7, 9, so this is 8. So now, looking down column 9, I need 1s, 2s, and 4s. This is a naked single. That's a 1. This is a 2, 4 pair. Now, what do you think this means? I don't know yet, but I'm very much more excited than I was a few minutes ago when I couldn't do anything. Maybe we can do that Renban now. It's got to have an... I don't know, actually. It's got to have an... Oh, maybe that cell. Maybe that's a more sensible cell to think about. That's got to be 4 different from 8, and it isn't a 4. So that's a 1. Oh, it's a 1 or a 2. It can't be 3. So actually, the overall panoply of digits on orange lines, remember they have to be a consecutive sequence. Even if this was a 2, we're looking at least at 2 to 8 now, aren't we? So things like... Oh, I tell you what might be interesting. Because 4 and 8 are definitely on whispers, on the Dutch whisper, there must be a 5 on a Dutch whisper somewhere, and 5 is a really difficult number to put on a Dutch whisper because it can only partner up with 1s and 9s. I've got a horrible feeling I'm about to get stuck again, actually. Because... What? What's easy? What's actually easy to do here? I know that's 1 or 7. I know one of those three is 1 or 7. I don't know. It can't be this, can it? I don't know. Oh, I suppose, okay, this Renban isn't a 1-2 pair. Because that would kill that cell off. If this was 1-2. It's not 2-3. And it's not 3-4. It's not 4-5. It's not 5-6. Oh, I see. All right. So it's from 7, 8, and 9. And therefore it's got 8 on it. Because it must be a consecutive pair. But, oh, wait. Wait. Well, okay. I mean, if I can make, I think this is realistic, isn't it? What I was going to say is, how could that be an 8-9? Because if this is an 8-9, then 7 hasn't appeared on a Renban. But the only way it could appear on a Renban is if there was a Renban dot rather than a line. Because obviously if you tried to put 7 on a 2-cell Renban and it couldn't have 6 or 8 on it, it could never have a consecutive pair. So I think that's real. That feels. There's no a Renban line. It does say purple lines. It doesn't say purple dots. I hope that's not a step too far. It feels logical to me to do that. I'm not actually sure it's going to help me very much, even though it says there's an 8 in one of 3 cells there. Yeah, I suppose what it does tell me is if there is another Renban line in the puzzle, that won't have 9 on it now, because it couldn't have 8 on it. I mean, it's got to be this, hasn't it? Which is completely terrifying, because how on earth? Okay, so if that is high, these would have to be from 2 and 3. Because they couldn't be 4. 4's already appeared. So these would be 2 and 3. But that could still be 7 or 9, I think. Wow. There must be some subtlety I can grasp. Oh, I see. Hang on. 6 is on this line. That's going to be it. Right. Can 6 go in the middle? No. Got you. That's beautiful. It's beautiful setting, Belamis. Beautiful. If this was 6, these 2 cells could only be 1 and 2. By Dutch whisper logic, you need digits that are 4 different. Actually, and 1 can't be one of them. But I was actually looking at that cell and thinking, then that cell couldn't exist. But 6 is not there. So 6 is in one of these. So this digit is a 1 or a 2 and isn't a 1. So it is a 2. And therefore this is a 1. Yay! Okay, now I've exposed some entropic lines. Oh, it's going to be tricky to... Can I do that? That's a bit tricky. Now, one of these is a 6, and the other is going to be 7 or 9, because it can't be 8. So if one of this can't be 9, that's not true. That's not true. I was thinking about the need to put 5 on a Dutch whisper. And we do need to put 5 on it. In fact, we need to put all of the numbers from 1 to 8 at least. Wasn't there a rule about Dutch whispers having to be? No, it was the entropic lines have to be at least 3 cells long, but there isn't a similar rule for the Dutch whispers lines. Because I was wondering if we could assume these were therefore going to extend. I don't know. I'm not sure. That one's going there. So 2 is in one of these cells by Sudoku. I don't know. I think it's going to be the entropics then. So, what on earth can we say about those? It's quite difficult to put 8 on them. None of those can be an 8, but that could be... Oh, no, that can't be an 8, apparently. Oh, maybe that's interesting. Maybe it's hard to put... Well, it is actually impossible to put 8 into any of those positions. So if 8 is on an entropic line, the thing is that could go downwards or diagonally or there even, maybe. I never like having to rely on sort of funny graphics in Fog of War, so I would be upset if I had to make that I make the assumption this couldn't be an 8 because of that line not being able to do that, because if it did, there would be a tiny peach piece in that corner. Oh, I don't know. Oh, I suppose, okay, one of these digits is high, because that's a 3-cell sequence, so one of them's got to be a 7, 8, or a 9. It can't be an 8, so it's going to be a 7 or a 9. That's a 7 or a 9. So in this row, there's sort of a 7, 9 floating pair between those digits, which means these digits are from 2, 3, 5, and 6, which is of no use nor ornament. Oh, hang on. No, it's easier than that. No, it's much easier. The point of this being 7, 8 is that the high digit here is a 9, isn't it? And that's going to give me a corner digit. Yeah, and now? Okay, well, it was still good. That was still definitely progress. Anything like that we will happily take. So, okay, so this can't be 9. Because then those 3 would need a high digit in them, and this would have no option at all. So that's not the 9. So this is either a 2 or a 3 if it's low, or a 5 or a 6 if it's high. This digit, if this is a 2 or a 3, this is 1, 2, or 3. And if this is 5 or 6, this is 4 or 5. I see that. I mean, forgive me. I hope you can forgive me for that pencil mark. I know it's disgusting, but it's not inconceivable that we need to think about things like that in this sort of puzzle. So what do you think we do with this? I haven't got a Scooby-Doo. So we've got... oh, I see. Right. So now I'm going to think about the high digit in these 3, which is not 8, and it's not 9, because that's appeared already. So there is a 7 in one of those, which means this digit is a 1. Oh, this is just fantastic. It's so satisfying. Now that's a 7, because we know they added up to 8. This is now a 5, 6 pair. I mean, I will say, I think this is a very, very challenging puzzle, but in all the best ways, in the sense that the constructor has clearly thought so hard about some of the decisions and the choices that are being made here. Now, so 7, look, is in one of those 3 cells. That's come out of nowhere. Oh yeah. Now look at this sequence. That's got to have a low digit on it now. It's not a 1 or a 3, so it's a 2 that isn't going there. So 2 is in one of those cells. That takes 2 off the top line. So we're very close to forcing this to be high. Sorry, it's forcing this to be high as in not 3, not a 1, 2 or 3. And that would mean if those were both middly, I don't know. So, okay, so we know 2 and 7 are on here. And we need a 4, 5 or a 6 into one of them. Oh, I know. Oh, wait, oh dear. Hang on, there's another implication here that I'm suddenly realizing. I've now got a 2 on an entropic line and a 9 on an entropic line. So I know I'm looking at least 8 cells on an entropic line. But there's the rule that says each entropic line is at least 3 cells long. So if I did have another entropic line in the puzzle, that's not possible, because that would be 10 cells of entropicalness. So one of these lines extends, and it's going to extend. Oh, now hang on. This is to do with the 8. Yeah, but why does it extend? It's because 2 is on an entropic line and because 9 is on an entropic line. There are 8 digits at least on entropic lines, and so far I can only see 7 of them. So one of them needs to extend at least by 1 cell, and yet because 9 and 2 are on lines, 8 is on a line. Well, 8 can't get on this line. 1, 2, 3, 4. Even none of those cells can be an 8. Why is my phone buzzing at me? So 8 goes on this line, and it doesn't go there. But this line does extend more. So if that was 7, I don't think that works. Because if that's 7, the place that 8 would appear on this line would be 3 cells later, which would be the 6th cell on this line. But then there would be 10 cells overall again, so that is not 7. So that's 2, or it's middly. And if that's 7, then one of those 3 is going to be the 8. But if that's 7, then I think the 8 could be in a hole. It probably could even be up there. Actually, I haven't even thought of that. Could it be up there? Oh, it could. Oh, goodness. Wow. Okay. If that's 2... Actually, I tell you what else is quite difficult to put on an entropic line, and that is 1 now. Oh, yeah. That's what we do next. Right. These 3 need a low digit, and it's not a 2 and it's not a 1, so there is a 3 in one of those, which means this isn't a 3. Okay, and those are not 3 now. So these are from 2, 5, 6. And one of them has to be a 2, because otherwise 2 in the top row is going on the entropic line. Now, can we do something with that knowledge? Sure we can, somehow. Just need to work out how. It's not Sudoku or something, is it? It could be. 4 has to go on an entropic line somewhere. I'd love to know if the overall panoply of entropicalness is 8 cells or 9. If it was only 8, then we would be cooking with gas, because we would then know that we'd know this was a 7, that would make this a 7, this an 8. Oh, I'll tell you something I've just realised. Because 7 is in one of those and 7 is in one of those, where's 7 in column 3? And it's in one of these 3 cells, so it's not there. So that's become 6 or 9 now. Does that help us? 9 is in one of these 3 cells by Sudoku. Wow, I don't know. If that's 9, does that have to be 5? Or maybe that could be 5 again. I was just trying to think about the need to put 5 on a Dutch whisper. I don't know. Okay, I'm stuck. I am officially stuck. I'd love not to be stuck, but there's obviously some subtle point, probably around the entropic lines, I'm not sure, which would help me to deduce something. 7 is in one of those 3 cells by Sudoku. You can tell I'm stuck. I'm being reduced to Sudoku here. One of these is 5 or 6. Is there some way I'm meant to know which? Probably is. I don't know what it is. Or 3924. The other digit on here is 4, 5, or 6, isn't it? So one of these is 4, 5, or 6. 9 in row 4 can't repeat on this entropic line, so it's in one of 2 places. Is that helpful? So this is 9 and 4, 5, or 6. I don't think that's enough, alas. Is there some maths point that I'm meant to understand? Hang on, let me just look at the rules again. Is there something that I'm meant to appreciate here? I have no idea. Something I've just noticed is if that is a 2, you could ask a question about where 2 goes in this box. In fact, that is a general point. That digit, where does it go in this box? It can't go in its own column. It can't repeat on an entropic line. It's not a 7 or an 8. So it goes there. Those are the same digit. Now, does that allow us to say anything clever? Well, yes, I suppose it does, because that does tell us that this line doesn't extend anywhere. So this is the full length of this entropic line. Now, let's think about what this can be from a Sudoku perspective. Can it be 2? Yes. Can it be 4? Maybe. It can't be... Oh, no, maybe it can. Can it be 5? I was going to say. It can't be 6 because of this one. It can't be 7. It can't be 8. And it can't be 9. So it is only 2, 4, or 5. That's really quite... Oh, it's not 2 because of that. Oh, that's done it. Yes. Right. That's beautiful. Yeah. This 2 is looking at that. So because... I just want to recheck this now. So if that was a 2... Yeah, that's completely logical. Doesn't work. Right, so this is the middly, and the 2 on this line, which is necessary now, is there. So this is 2. Didn't clear the fog. This has to be 7, I think. This is 7. This is 8. Yes, yes, yes. So, okay, it's giving me a white dot there. There's got to be this digit. Oh, there, yeah. Where's that digit? It's there now. By Sudoku. Because it's see, there's a 4-5 pair in row 9. What a puzzle. This is a proper workout, isn't it? Okay, come on. So now what do we know, if anything? Oh, what? Actually, that's been cleared. So we don't back out here. Not that I was particularly expecting that we would, but the entropic line, which we know is extending, now doesn't go to that cell. And in fact, the next... Oh, yeah, right. So we need an 8 on this entropic line somewhere, but that's going to be in 2 cells' time now. So there's the next cell on this is a 1. And I don't know. It's going 1-8 this in some way or other. I don't know where. But what that... Yeah, this is huge. This is such a beautiful idea. Right, let me go through the chain of the logic now. So, this line has to be 5 long to get to an 8, which we know is necessary because overall, because there's a 9 on the line and a 2 on the line. So there's an 8 somewhere on an entropic line, and it can never be on this one. This can't grow. So this one grows because there's no other entropic lines. You can't have two cell entropic lines from the rules. So this has to grow, and the 8 on it is not going to be the next cell because the next cell needs to be a low digit. And that's going to have to be, it can't be a 3, that's already appeared up there. So it's going to be a 1. But that means this isn't a 1. And if this isn't a 1, this is now a 4 or a 5. I'm going to colour that. I'm not proud. Actually, I'll make it dark green. Now this one is not 3. I know what this is actually, because now we've had this one on it. We had lime green on an entropic line and dark green on an entropic line, and they're a 4-5 pair. So this is a 6. Didn't clear any fog. I'm not surprised. So these are a 3-9 pair at the top there, and these... Oh no, oh okay, that's all right, it's okay. This is a 1-2 pair, which is a really interesting pair in the context of this white dot, because if this was a 1, this would be a 2, and that wouldn't exist. So this is a 2, this is a 1, this is a 1, this is a 2, this is a 3, which means this is now 7 and 8. And we can get these digits even if we can't solve them. This is 4, 6, 9. And that's not 6. And 3 is in one of those 3 cells now. And we've got to remember we're not going into the 1 there now, because there's no line in that cell. So the next digit is one of those 2 is a 1. And then the 8 could be just about anywhere. It's bizarre. Oh. So I don't see how to do that. That's very, very distressing. bother. I don't know how to. I really don't. I mean, actually, you look at the grid in this position, and you sort of say, okay, well, there must be something I can really work on here. And apart from this 1-8 pair, I know is dangling off the end of this thing. I'm not sure what it is I'm meant to be thinking about. So the entropic lines is the full set. It's all 9 digits. Oh, it must be Sudoku. Is it Sudoku? 8. Ah, it nearly is. 8's got one of 3 places in box 1 and 6. Oh, this isn't a. Oh, yeah. Do you remember there was a 6 on that line? Well, now I know where it goes. So that's probably what we needed. Oh, didn't clear the fog. I can't remember a fog of war puzzle in which clearing the fog, that 3 not clearing the fog early was brutal. Okay, so I don't know. I'm not sure. If that's 9, that would be 9. 9 would be in one of those 2. What about 6, 9? Oh, I don't know. It must be that it's probably Sudoku, isn't it? 1 is in one of those 3. I've got a 4-5 pair in column 1. So the digits I need in column 1 are 1, 3, 8, 9. But that's a horrendous sequence of options, isn't it? Look, I don't think any of those cells are being impinged upon by anything. Although, no, actually that's not strictly true. This can't be a 1, because I do think that this is getting a 1 from one of those cells. So that can't be a 1. And if this was a 1, that couldn't be a 1. And that would actually place the 1 in column 1. Oh, I wonder if there's some reason this can't be a 1. I don't know. Wow. Wow. Or is there some reason this can't be a 9? Because I've still got it in the very back of my mind that we've got to deal with 5 on the whispers. Got 1 to 8 on the whisper. I've also got to deal with 3 on the whispers. So if this was 7, maybe there's some meta logic we can do. If this was 7, I would have 3, 5, and 9 to place on the whispers. But I could put a 9 in the middle of a 3, 5 pair. Okay, but if this was 7... Sorry, if this was 9, then 7... Where would I put 7 on a whisper? Oh, this is... I mean, this would be a beautiful point if that is actually valid. Okay, here's the thought. If I make this digit here, a 9, then if we think about what we've got left to put on the whispers, we've then got to use all the digits 1 to 9 on the whispers. And the digits we'd have left to place are 3, 5, and 7. But there's nowhere I can put the 7. I would need to put it on a whisper. Ah, no, I'm wrong. 3 and 7 are 4 apart, you idiot man. No, it's tricky, this. No, oh yeah, you could have a 2-cell 3-7 line. I was mixing up my German whispers and my Dutch whispers. Silly Simon. Okay. I take it back. I still think this is going to be a 7. But I think you can get away with it being a 9. And then this would have to extend into a 5 somewhere, because otherwise you can't deal with the 5, because the 5 can't attach to the 1. And then you'd be left, the 5 couldn't attach to anything, so you'd be left with putting a 3, 7 in the, I mean, it's not going to be something like you can't, no, you could have a 3, 7 here. Wow. Okay, that's quite difficult, but I think possible. So it's something else. Who knows what? Because I don't know. I mean, I genuinely, I'm getting the fear. I'm getting the fear about what on earth I'm meant to be looking at here. Is there some cell that is under ludicrous pressure that is hard to spot? That cell. That does see quite a lot of digits, because it sees everything in its row and an 8-7 pair. So it's 1, 3, or 9. Now, can we do better than that? Probably not. But I mean, it's still quite an interesting cell. 6, 1. I mean, fair play to Belamis that this is still. I mean, what on earth are you meant to do in this position? It's is it the extension of this? Oh, I've got a 1 there. Yes, it is. Oh, I'm so sorry. Right, at some point, remember this is meant to extend into a 1 and then an 8. Well, that can't be the 1, and that's been available for... Oh, and a C. That's why this has been shown, to stop you thinking it could go back there. It's got to be here. Yeah, there we go. And then we can see the extension. Oh, look at this. Oh, it's such a relief. Right, and that wasn't too bad. That was just me not remembering stuff I'd already deduced. Right, okay, so it was getting that 1-2 pair I could have immediately done that. Okay, so what does this do then? Well, it's revealed things. I've got another Renban. I can't put 9 on a Renban. There's an 8-7 there, so that's got to be a 3. So that's a 9. This isn't a 3. I've had 5 on a Renban, so this can't be a 3, 4, 5 Renban. I can't have a 1 on it at all by Sudoku. So it's not a 1, 2, 3 Renban. So it is a 2, 2, 3, 4 Renban, and they are 2 and 4. And I know the order actually. 2, 4. That seems to have to be 7. 7, 8. Oh, please. It would be really lovely if this suddenly got easy. 8's in one of those two, so we can ask where 8 is in the bottom row now. It's either there or there. I've got some sort of... Oh, it really could be here, because this is a parity line. But that is an... let's extend this. This digit is meant to be even, because that's definitely odd. So that's not 7 anymore. So 7 now is placed in the bottom row. Because this can't be 7, and this can't be 7, this can't be 7, that is 7. How many 7? I feel like we've got a lot of 7s now. Oh no, we've got that sort of little congregation left to figure out. Oh, no, this is a stronger parity line than I'd realised. I need that to be even, but it's not 2, 4, or 6, so it's only got one option. That's got to be... Oh, that's the end of the line as well. Travelling Wilburys making an appearance in a Cracking the Cryptic video. That's what we like. Now, this is an 8 by Sudoku. Yes, it is. That's good. So how many 8s have we got? Very nearly all of them. Got a little X-wing of 8s left there. What do we need in this row? 1, 3, 9. Don't know how to do that. Right. Okay, so what has this 2-4 has done some things over on that side of the grid. Now all I need is this 4 to look at one of my green colours, and that would be very helpful, but it doesn't seem to want to. Or maybe 2, 3, 5, 5, 7, 8, 9. That digit is 5 or 9, I think. C's a 7, 8 pair. Is there more Sudoku to be done? There could be. Let's check row 7 a bit more carefully. That one, I think, is 5, 8 or 9. Can we do anything with that? What about Ren bands? 2, 3, 4, 5, 6, 7, 8. So the Ren bands are over. There's no more Ren bands, because if there was, it would be a 1 and a 9, and they are not consecutive in their own parish. Now, oh dear. Okay. I should extend that down just so that it makes me feel happy. What do you think we do next? Is it going to be... I don't know. I think that's going to be 9 and that's going to be 5 on this Dutch Whisper. 7s. Seven. I mean, there's a horrific argument you might be able to make with 3s and 7s now as well. Given that that 7 can't be attached to anything, I might come back to that thought. I'm thinking about this Dutch Whisper, but let's not rush to get involved in such difficult points. There's probably something easier. I've just got to spot what it is. 2 is no longer in this cell. 4, 5, 8, 9 in this column. So this is, oh, that's 5 or 8 only. Yeah, okay, that's interesting. Is that true? I don't actually trust that at all. In the column, yeah, I think that's 5 or 8. That seems to give me these cells as being a 5, 8, 9 triple, which is sort of surprising. That's going to make that a naked single. Is that true? I mean, that feels ludicrous. Right, row 8, column 4. What can that be? It can't be 1 or 3 or 4. Now, for some reason, I think it can't be 5 because of this 5, 8, 9 triple. Well, actually, that's true. It can't be 5. Where's 5 in row 7? It's in one of those two. So it isn't 5. It's not 6. It's not 7. It's not 8. It's not 9. It's a naked single. That's a 2. I mean, that's absolutely barbaric. Barbaric, I tell you. Right, that's 2 now. That's 5. So this is 9. This is 7. Is that what I expected? I think that is what I'm not sure, actually. That's 7. That's 8. That's 5. This is 8. Okay, well, this is very good. Now, this is a 1-3 pair. Okay. And now, oh, okay, and we're going to have to give this some thought. Because now I think I have got a horrible Dutch Whisper left to find. Now I need 5, 6, 9. This digit, bother. 5, 6, or 9 are all options. This is a 4, 6 pair. But 9 looks like it might be doable. 9 in this row. It's only got one place. Yep, that's good. This is 4 by Sudoku. That's great. Look, that's given me some more thingies. Yeah. Okay. This row needs a 5, a 6. That's become a 4, which is that digit. So this is a 5 now. We're really close to finishing. Famous last words, but I think we really are. 6 by Sudoku is there. Now, what do I need in that row? 3, 9. Bother. What do I need in this row? 1, 3, 5, 9. That's not 1. This is 1, 3, 5. This is, oh, no. 3 or 5? Really? Really? Ah, okay, that can't be 9. So in this column, 9 is in one of these two. So 9 comes out of those two cells. No. Oh, no. I've got some weird pattern left in the grid. Okay, it's going to be to do with this, isn't it? Oh, you know what? Here's a different thought altogether. What's that digit? How is that not 9? If this is, say, a 3, then I've got to put... Well, then it just can't work, because 4 is placed everywhere. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's how to do it. That is how to do it. If this is 1 or 3, I have to put 4 on a parity line, because I have to put 4, 5, 6, and 7 on a parity line. And 4 can't go on a parity line because all the 4s have been exposed to the elements. So that is a 9. Okay, that didn't do anything. Oh, yes, it did. Yes, it did. Now that is a 9. That's a 3. Okay. Oh, please don't be unkind. I don't believe it. Okay, so it's the Dutch whisper trick then, is it? I've got 3, 5, and 9. No, I haven't. That's not true. Well, it is true. No, it is true. I need to put 9 on because look at the Dutch whisper cornucopia. I've definitely got to put 3 and 5 on Dutch whispers because I've got 1 and 8 on Dutch whispers. Now, the problem is that given I've got to put 5 on a Dutch whisper, it can't partner 1, which would have been one of its options. That's already appeared. So it must partner 9. So somewhere in the fog, there is well, what's the order going to be? It's going to be 5, 9, and then I'm going to put the 3 next to the 9. So there is a 5, 9, 3, or 3, 9, 5 Dutch whisper somewhere in the grid, which is a 3 cell. Well, it's not there. There's no 9. It's not there. It's not there. So it's here. This has got to have... Okay, that could be 9 if that goes 9, 5, 3. Is that the only way to do it? That's what I'm wondering. So 5, 9, 5, 9, 3. Is there any other way of doing it? Oh, hang on. Why can't I just do 5, 9, 3 like that? Okay, no, I don't know. But surely the point is this isn't 1. If that was a 1, there is no way to constitute a 3-cell Dutch whisper. So this is 5. That's really clever. It's really clever. And this, exposing this, I expect to then disambiguate which order they go in. Yeah, because it points the Dutch whisper line. It's just, that is ridiculous. Good grief. And, look. look what I'm getting down here. This is a 3-9 pair, which is totally resolved, don't worry. This is a 1. I'm going to leave that for last. But 5 must go next to a 9 on a whisper. That's a 3. That disambiguates this pattern. And the last cell in the grid is a 3 in the corner. And that's 3 in the corner. That's 3 in the spotlight, losing its religion. Wow. What a puzzle that is. That is seriously challenging, I think. But the logic at all steps, it never really got easy at all. There were some moments where I could have been faster, like I think when I got a 1 here, I could have got this quicker. But it never let up. It was always interesting. It's a brilliant puzzle. Let's make sure all the 4s are that colour and all the 5s could be dark green, just to make sure that it must be correct, surely. Yes. Wow. Wow. Brilliant. Belamis, that is brilliant and very, very challenging. Loved it. Let me know. I mean, what a start as well. You just got a few cells of region sums and arrows. And the logic there was not easy. Anyway, let me know in the comments how you got on with the puzzle. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.